Warning, temperature critical, 400 degrees Celsius and rising. Hull integrity compromised.
But we're getting ahead of ourselves. Let's start from the beginning. This is the last photograph ever taken on the surface of Venus. The machine that took it, the Soviet Venera 13, it was engineered to survive 30 minutes. It lasted 127. 2 hours, 7 minutes. Transmitting from inside what can only be described as a chemical furnace the size of a planet. Then, the temperature melted its solder. The pressure split its seals. The acid dissolved its housing. The brightest star in our sky, named after the goddess of beauty, they had no idea what was hiding under those clouds. Venus is the same size as Earth, same mass, same rocky composition, same distance from the Sun, give or take. But here's the first thing that should unsettle you. Venus spins backwards. Every other planet in the solar system rotates counterclockwise. Venus doesn't. Nobody knows exactly why. And 4 billion years ago, it looked like this. Oceans, coastlines, water vapor, maybe even the raw chemistry for life. Look at it. This could have been home. Something went catastrophically wrong. A runaway greenhouse effect, CO2 trapping heat, heat releasing more CO2 trapping more heat, a feedback loop that never stopped. The oceans boiled, the water vapor trapped more heat, the rocks themselves started outgassing carbon dioxide, and the temperature climbed and climbed until it settled at a number so extreme it sounds fictional. If you dropped a block of lead on Venus, it would melt into a puddle. Every solder joint in every phone, every computer, every piece of technology you've ever touched, liquid in seconds. So here's what we're going to do. We're going to put you on this planet for 24 hours. We're going to drop you through an atmosphere of acid into an ocean of supercritical carbon dioxide, onto a surface that melts metal. And we're going to walk you through, hour by hour, exactly what Venus does to you, to your body, to your technology, to your mind. You already saw hour 23. You saw how this ends. Now let me show you how it begins. You're on Venus. Welcome to hell. Look at those numbers. Let them settle. 465 degrees Celsius. Outside, right now, 15 centimeters from where you're sitting. 92 atmospheres of pressure, the equivalent of being 900 meters underwater. The atmosphere pressing against every square centimeter of this capsule with a force of 93 kilograms. And now, let me tell you what's above you, because you can't go back, not through what you just fell through. Between you and open space, there are 100 kilometers of atmosphere, and every layer is worse than the last. The first 10 kilometers above you, the atmosphere is so dense it behaves like a fluid. You didn't fall through air to get here. You sank, through an ocean of supercritical carbon dioxide, hot, thick, and crushing. And then the clouds. Not water, sulfuric acid. 17 kilometers of concentrated acid fog, dense enough to burn through metal, bone, anything organic. Your capsule fell through this layer. Its exterior coating is already damaged. The acid started eating at the seals the moment you entered the clouds, and it hasn't stopped. And here's the cruelest part. 60 kilometers above you, the upper atmosphere, the temperature is room temperature. The pressure is close to Earth's. There's even water vapor. It is the most Earth-like environment in the solar system outside of Earth. And it might as well be on another planet entirely. Because between you and that layer, there are 60 kilometers of acid, heat, and pressure that no machine has ever survived traveling upward through. You are at the bottom of an ocean, 100 kilometers deep, with no submarine, no way up, no way out. The capsule is all you have, and the capsule is already being eaten. Let me paint this for you. The first thing you'd notice is the light. It's not dark. The surface gets as much light as an overcast day on Earth, but the quality of that light is wrong. There's no sun in the sky. You can't see it. The atmosphere is too thick. Instead, the entire sky glows, a uniform, oppressive amber. Light comes from everywhere and nowhere. The second thing is the silence. The winds at the surface are less than 1 meter per second, a gentle walking pace. But the atmosphere is so dense that you feel it. A 1 meter per second breeze here pushes like a 30 kilometers per hour wind on Earth. Now, let me tell you what's on the other side of this wall. What I'm about to describe isn't speculative. This is thermal physics. This is what's happening right now, 15 centimeters from your face. At 465 degrees Celsius, the fats in human skin spontaneously ignite. Auto-ignition starts at roughly 300 degrees. The water in your tissues, 60% of your body weight, would flash to superheated steam, but 92 atmospheres of pressure would keep it trapped. Your body would be pressure cooked and charred simultaneously, in less than a second. That's what's outside, right now. That is what the cooling system, the seals, and these 15 centimeters of engineered metal are holding back. You press your face to the porthole. The view is unlike anything any human has ever seen with their own eyes. The landscape stretches to an amber horizon that feels too close. Venus is slightly smaller than Earth. The curvature is tighter. It feels enclosed, claustrophobic. Even the outside feels like a room. Nothing moves. No wind you can see. No life. No erosion patterns you'd recognize. Just scorched basalt, shaped by nothing but volcanism, pressure, and unfathomable time. You are looking at the floor of an ocean that has no water, through a window the size of a dinner plate, and there is nowhere to go. Around hour 5, something changes. You feel it before you see it. A subtle shift in the capsule's pressure on the landing struts. Then, through the porthole, dust. Fine volcanic dust drifting horizontally in thick, syrupy streams. The wind. Less than 1 meter per second. On Earth, a candle wouldn't flicker. But in this atmosphere, even a breeze carries enormous force. 30 kilometers per hour equivalent. You hear it now, not as a whistle, but as a low, pressurized moan against the hull. The planet breathing. And the wind carries heat from every direction. There are no cold spots out there, no shade, no shelter. The atmosphere is the oven. And inside this capsule, the cooling system is the only thing standing between you and equilibrium. On Earth, you can hide from the sun. On Venus, the heat is the atmosphere. And the atmosphere is everywhere. Then, a flash above, muffled, filtered through 60 kilometers of dense atmosphere. Venus has lightning. Not from thunderstorms, from volcanic ash and sulfuric acid reacting in the clouds high above you. You can't see the bolts, but the electromagnetic pulse bleeds through as a ghostly glow. Beautiful from a distance, terrifying when you remember what's generating it, an ocean of acid churning above your head. Now, here is something most people don't know about Venus, something that makes this experience genuinely, existentially nightmarish. A day on Venus, one full rotation, takes 243 Earth days, longer than its year. Night on Venus lasts 121 Earth days. You're here for 24 hours. If you arrived at sunset, you'd spend your entire stay in a darkness that won't lift for 4 months. But here's the truly disturbing part. The temperature doesn't change. On Earth, night brings cooling. There's a rhythm, warm and cold, light and dark, that all life is synchronized to. On Venus, there is no rhythm. The atmosphere is so thick, so efficient at trapping heat, that the night side is exactly as hot as the day side. The poles equal the equator. Dawn equals midnight. 465 degrees. Always, everywhere, without variation, without mercy. For the entire history of the planet, the same temperature, the same pressure, the same thick, toxic, amber-lit suffocation. Earth has weather. Earth has seasons. Venus has one temperature, and it has it forever. By hour 9, the silence starts to erode your certainty that you're alone. Because Venus is not silent. The atmosphere hums, a constant subaudible vibration. The planet's mass of CO2 pressing against the surface, against itself. Lightning 50 kilometers above. You can't see it, but the electromagnetic signature bleeds through. Static crackles, muffled, like thunder heard from inside a sealed room. And then, the sound the Venera landers recorded but couldn't fully explain. A rhythmic, low-frequency pulse that some attributed to wind, others to the lander settling, and others simply marked as anomalous. It was probably the wind, almost certainly. But at hour 9, alone on a planet that's been dead for billions of years, in 465-degree darkness, almost certainly doesn't feel like certainty at all. There is growing evidence that Venus is volcanically active. In 2023, researchers found a volcanic vent that had changed shape between two orbital passes just 8 months apart. Venus isn't dead, it's alive. And on a volcanically active planet with this atmosphere, an eruption wouldn't look like anything on Earth. No ash column, the atmosphere suppresses it. Instead, rivers of molten basalt spreading across the surface. If an eruption happened within 50 kilometers of you, the lava wouldn't kill you. The pressure wave through the super-dense atmosphere would. A shock wave through fluid. "18 hours in, 6 remaining, and your capsule is dying. The exterior coating, designed to resist sulfuric acid, has thinned by 40%. The acid doesn't stop, continuously. A slow, patient chemical dissolution. 18 hours in, 6 remaining, and your capsule is dying. The exterior coating, designed to resist sulfuric acid, has thinned by 40%. The acid doesn't stop, continuously. A slow, patient chemical dissolution. The internal temperature is 44 degrees and climbing. The cooling system is consuming power that wasn't planned for. Your batteries had margin for 24 hours. That margin is gone. And this is when you understand something no reading can prepare you for. Venus isn't trying to kill you. That implies intent. Venus is simply being what it is. Your existence on its surface is a thermodynamic impossibility that the planet is passively correcting. You are not being attacked. You are being dissolved back into equilibrium. At hour 22, the cooling system fails. Not with a bang, it simply doesn't cycle back on. The compressor tries. A click, a whine that rises and falls away. Then, nothing. The interior temperature climbs, 70 degrees Celsius. Every breath is painful. 80 degrees Celsius. Cognitive function fails. Heat stroke begins. 100 degrees Celsius, your proteins denature. At the molecular level, you are being unwritten. The seal on the lower access panel fails at hour 23. The breach is small, millimeters, but at 92 atmospheres, millimeters are enough. The supercritical CO2 floods in, not like air, but like water through a hull breach. Dense, heavy, scorching. Interior temperature spikes. 200 degrees Celsius, 300 degrees Celsius, 400 degrees Celsius. Electronics arc and die. Plastic ignites. Metal warps. So, why should you care? Why does it matter that a planet 108 million kilometers away is a boiling, crushing, acid-soaked nightmare? Because Venus is a warning. Venus had water. Venus may have had a breathable atmosphere. Venus had the conditions for life. And then its greenhouse effect ran away. CO2 accumulated. Temperatures rose. Oceans evaporated. A feedback loop that didn't stop until every drop of water was baked into the sky and lost to space. Venus is what happens when a planet loses control of its climate. I'm not saying Earth is about to become Venus. The physics are different. But the mechanism, the feedback loop, is the same mechanism currently, measurably, warming our own planet. Venus isn't a prediction. It's a proof of concept. A planet-sized laboratory showing us what happens when that loop runs to completion. We study Venus not because we want to go there. We study it because it's a mirror, a dark, distorted 465-degree mirror showing us one possible future. And right now, we're the only ones who can decide whether that mirror stays a warning or becomes a prophecy. Venus doesn't remember you. It didn't notice you arrived. It won't notice you're gone. 1,000,000 years from now, the basalt where your capsule sat will look exactly like the basalt around it. Same temperature, same pressure, same amber silence, forever. And if you want to see these videos, subscribe.